Alright, we are continuing with section 13.3 concavity, and this is problem number 23. We have x, so we have y, f of x, equals x plus 1 over x minus 1, which is going to require us using the quotient rule in order to get the second derivative. Let's do that. But let's first establish the fact that x equals 1. F of x is not continuous at that point. So it cannot be a point of inflection, but we should still consider the intervals between that number. Alright, let's take the first derivative using the product rule. Derivative of the first function is 1 times the second function minus the derivative of the second function, the denominator, times the first function, which is x plus 1, and that's minus x plus 1, so it's minus x minus 1 over x minus 1 squared. Let's take the second derivative. So as far as the numerator goes, we have x minus x, the x's cancel out, and we're left with negative 2 on the numerator. So let's just turn this into what it actually is, which is now negative 2 times x minus 1 to the negative 2 power. So it'll be easier to take the second derivative now. So we have we have a composite function, so we'll use the chain rule. So the derivative of the outside function, so that'll be negative 4 times x minus 1 to the negative 3 power times the derivative of the inside function, which is just 1. So the derivative is negative 4 times x minus 1 to the negative 3 power, or negative 4 over x minus 1 cubed. So again, the only number to consider here is 1. There are no inflection points, but we can identify the behavior of the graph as far as concavity goes before and after the value 1. So let's look at the two intervals, negative infinity to 1 and 1 to infinity. And we're going to look at x minus 1 cubed, negative. And that'll establish the sign of the second derivative, and thus the behavior of the function. Alright, so between negative infinity and 1, let's pick 0. 0 minus 1 cubed is going to be negative, times the outside negative will be positive. So the function will be concave up. Between negative infinity and 1. Alright, now let's look at the interval between 1 and infinity. Let's plug in 1. 1 minus 1 is 0. Cubed 0 times negative is going to still be 0. Let's plug in 2. 2 minus 1 is 1 cubed. That'll give us a negative. So let me see. It's going to be... Wait, between negative infinity and negative 1, let's plug in 0. That's negative. I did something wrong here. I know what I did wrong. The second derivative, when I took the second derivative, it should have become positive. Okay, now I know what I did wrong. Okay, so now that I fixed it, I'm sure some of you identified that I made a mistake earlier. Thank you for tolerating that in these videos. I usually try to reshoot them if I screw up royally, but this was a small one, so hopefully it won't throw you off too much. Anyway, so the second derivative is positive 4 over x minus 1. Again, let's plug in between negative infinity and 1. Let's plug in 0. That's going to give us a negative second derivative over the interval negative infinity to 1, which means the function will be concave down. Over that interval. And then from 1 to infinity, let's plug in 2. 2 minus 1 is positive, so it'll be positive. The function will be concave up from 1 to infinity. So again, we don't have a point of inflection because the function is not continuous at x equals 1, but we can identify that the function is concave down from negative infinity to 1 and concave up from 1 to infinity. And we are done with this problem.